Okay, so today we're doing Leetcode problem 1265, and it's print immutable linked list in reverse. Now, what the problem states is that we're given an immutable linked list. We want to print out all the values of each node in reverse with the help of the following interface. So we have an immutable list node, which is an interface of immutable linked list. We're given the head of the list, so they're going to be passing in the head of this linked list as an argument. We need to use the following functions to access the linked list. We can't access the immutable list node directly, so we're not going to be able to call like node.next, node.previous. If it was a doubly linked list or node.val, we're actually going to have to just use these two methods on the list node object itself. So the input is only given to initialize the linked list internally. We must solve this problem without modifying the linked list. In other words, we must operate the linked list using only the mentioned APIs. So the way that we can approach this problem is two ways. The first way, and I think the easier way for this particular problem, is to do it recursively. The other way would be to do it iteratively with a while loop and a stack, but recursion builds a stack for us. So the way that it works is we are going to, let's see, if the list has, for instance, the items 1, 2, 3, 4, okay, what we want to do is we want to print out 4, 3, 2, 1. Okay, and the way a recursion works is when we call this function the first time, what we can do is just put this 1 in the call stack by calling the function again. So the stack will have 1. Then the stack will have 2, 3, 4, and so on. And then once we're done doing that, we're going to return or just go on to the next part of the function, and it's going to return 4, 3, 2, 1 in that order. So what we can do is we can check if head.getNext. So what this means is if there is a next value, so a node that's valid and not null, what we're going to do is we are going to call print linked list in reverse. And we are going to call head.getNext. Okay, so this is just going to call this function again, and this is where the recursive business kind of comes into play. So we're just calling this guy again with the following node. So if we had 1, 2, 3, 4, okay, and the first node was 1, what would happen is that we would be pushing 1 onto the stack. So the stack would have 1. Then on the next iteration, the stack will have 2, so on. Cool. So now that we've done that, so every time that we have something, this is going to keep getting called. So the first time that we have this function, it's going to get called. Then it's going to get called again with 3. Then it's going to get called again with 4. And there's nothing left to do. So what we need to do is take the things out of the stack. So after this if statement is ran those 4 times, we're just going to call head dot what's it called, print value, and that should work if I can spell. Oh, and I gotta invoke it. Sorry. There we go. Awesome. So like I said, recursion can be a little tricky sometimes because we don't really see what's going on and how things are getting pushed onto the stack. But just know whenever you make the recursive call, something is getting saved in the call stack of the computer itself. So that's why this works, because we're just pushing 1 onto the stack. And then before we ever even get down here, then we're pushing 2 onto the stack. Then we're pushing 3, then we're pushing 4. And then once that happens, all those times, then we finally hit this line. And then it's going to say, hey, print value. So we're going to print this value. That's going to pop off the stack. Then we're going to do this one. It's going to pop off the stack, and so on and so forth until we get to the end. And that is problem number 1265. I hope you found this video helpful.